Question A. How many ways are there of arranging 7 textbooks on a shelf? B. In how many of those arrangements is the single biggest textbook not at either end? A. The number of ways to arrange 7 items is just 7 factorial, and this equals 5040. Now, question B. It asks for in how many of those arrangements is the single biggest textbook not at either end. We already know the total number of permutations from A. So if we can find the number of ways that the single biggest textbook is at either end, then we use the total number of permutations to minus the number of permutations that the single biggest textbook is at either end. Then we can get the number of arrangements that the single textbook is not at either end. The single biggest textbook is at either end can be broken down into the single biggest textbook is at the beginning, or the single biggest textbook is at the end. So the single biggest textbook is at either end includes these two cases. The case 1, the biggest textbook is at the beginning. Case 2, the biggest textbook is at the end. Now, analyze the case that the biggest textbook is at the beginning. So for this case, we just put the biggest textbook at the beginning. Then we permute the left 6 textbooks. So the total weight is just 6 factorial. Now, for the case that the biggest textbook is at the end, similarly, first we put the biggest textbook at the end. Then we permute the left 6 textbooks before it. So the total weight for this case is also 6 factorial. Now, I use the addition principle to plus the weight for first case 6 factorial plus the weight for the second case 6 factorial, and this equals 2 multiplied 6 factorial. So this is just the number of arrangements that the single biggest textbook is at either end. Now we use the total number of arrangements to minus the number of arrangements that the single textbook is at either end. So we use the 7 factorial minus 2 multiplied 6 factorial equals, this should be 3600. So this is the number of arrangements that the single biggest textbook is not at either end. Now for question B, we can also think in another way. That is, these are the 7 spots for the 7 textbooks. We can break the process down into 3 steps. So step 1, we put a textbook at the beginning, and step 2, we put a textbook at the end, and step 3, we permute the left 5 books between beginning and end. Now let's go to step 1, put a textbook at the beginning. For step 1, we have 6 choices. to put a textbook at the beginning, because we cannot put the single biggest textbook at the beginning. Now we can put the left 6 textbooks at the beginning, so we have 6 choices. And step 2, we have 5 choices, because we already put a textbook at the beginning, and we cannot choose the biggest textbook. So we have 5 choices to put a textbook at the end. And step 3, we permute the left 5 books. So we have 5 factorial ways to permute the 5 textbooks. Then we use the product principle to multiply the choice for step 1, 6, multiply the choices for step 2, 5, multiply the choices for step 3, 5 factor. And this also equals 3, 6, 0, 0.